The K2-18 star system consists of a rather small star and 2 exoplanets. The James Webb Telescope recently discovered signs of life on the exoplanet K2-18b. Since then, the scientific world has been enchanted by this system, 120 light-years away. The detected traces of water, methane, carbon dioxide, and a gas called DMS reveal that there might be life forms on this water-rich world. James Webb finally provides the answers we were waiting for. It's official. The exoplanet K2-18b is rich in water, has an atmosphere, and scientists have found evidence of 3 other biosignatures: methane, carbon dioxide, and traces of dimethyl sulfide, DMS. Simply put, this means that we have never before found an exoplanet that shows so many signs of life. K2-18b is a hybrid world, a type of planet slightly larger than Earth and mostly covered with water. Their surfaces are composed of pure oceans or may have some land masses or continents. Ocean worlds can be climatically favorable to life, but this is not guaranteed. Scientists have discovered a surprising number of these aquatic worlds in the depths of the universe, and many of them are not conducive to life, despite the presence of water. There are boiling ocean worlds and even planets in this category that we must imagine as giant steam ovens. Therefore, water is not necessarily synonymous with life, but it is a fundamental prerequisite for biological life as we know it. In the case of K2-18b, we have a promising mix. The planet is medium-sized with a presumably solid surface. In depth, Webb has found traces of water, methane, carbon dioxide, and DMS in the atmosphere. This mix is clear evidence of the presence of bacterial life. On Earth, DMS is mainly produced by decomposition processes in coastal and wet habitats. The combination of these 4 aspects and the remaining parameters of the planet speak a very enticing language. It is scientifically very likely that there is some form of life or biological processes on the exoplanet K2-18b. The star K2-18 and the exoplanets K2-18b and K2-18c seem absurdly close, just 124 light-years away from us. In cosmic terms, this is a stone's throw away. For all the decades we have been searching for signs of life in space, we had this rich aquatic world right under our noses, but we did not see it. The star K2-18 has been known since the Kepler mission, and the Kepler telescope discovered the 2 exoplanets in the system. K2-18 is a red dwarf star, one of the most common stars in our galaxy. The mass and luminosity of these stars are on the lower end, yet these systems are no less suitable for life compared to ours. In star systems like this one, planets can orbit much closer to their suns and still be in the habitable zone. The Kepler Space Telescope was designed to search for exoplanets by monitoring the brightness of stars and detecting periodic dimming. Exoplanets appear in front of their stars as small dots barely visible to the naked eye. We need precision technology to detect these tiny trails and then learn more about them. Kepler discovered 2 exoplanets, K2-18b and K2-18c, but could only discover the basic details of the 2 planets due to the limited capabilities of the time. Kepler could not detect traces of water or determine the gases present in the environment. The James Webb Space Telescope can now do this. What do we know since then? Even though the Sun seems rather weak in this star system, K2-18c is still too close to its star. There are probably extreme conditions on this planet with very high surface temperatures and intense radiation. K2-18b is farther from its star and thus in the habitable zone, where temperatures could be mild enough to support liquid water. Precisely because this planet is so interesting, researchers have recently observed it closely using the James Webb Space Telescope. The thin spectrometers of the telescope can now provide detailed analyses of the chemical signatures of exoplanets. Besides water, we can now easily identify other gases and atmospheric clues. NASA scientists and the University of Washington are currently examining all the data obtained by Webb. Some of the best stationary telescopes on Earth are involved in these comparative studies. The scientists want to be really sure before making any assumptions. To verify the data once again, they build various scenarios based on all known details. Complex models show different possibilities for the planet's atmosphere and the relationships between its photochemistry. These simulations take into account both animated and inanimate scenarios. One possibility is that K2-18b has a dense hydrogen atmosphere and perhaps oceans, typical of so-called ocean planets. Researchers also hope that the simulations will provide further information to understand whether the observed amount of methane can be explained by geological processes or biological activity. To be really sure, we must be able to rule out the possibility that even inanimate scenarios could be responsible for this significant mix of gases and biomarkers. If models favoring biological life are confirmed statistically and computationally, we can state with high probability that K2-18b is the first exoplanet with signs of life beyond our solar system. Once we find a planet with these parameters, we can organize our search for life in space to specifically look for planets similar to K2-18b. If we find other exoplanets with these analytical data or similar structures, we will have something like a pattern. With each new discovery, researchers know better what to look for and which star categories and planet types are really promising. The exact opposite is HD 18973b. If you are now dreaming of soft extraterrestrial aquatic worlds, warm and tropical blue planets, oceans as far as the eye can see, perhaps land masses similar to islands where some birds or strange alien creatures live in a sort of paradise, hold on tight because here is the exact opposite of a cozy alien water world. HD 18973b. This exoplanet was discovered in 2005 and is about 64.5 light-years away from Earth in the constellation Vulpecula. This exoplanet is also very close and is practically one of our closest cosmic neighbors. However, this planet orbits very closely around its star HD 189733 and is much larger than Earth or K2-18b. HD 18973b belongs to the class of hot Jupiters. Hot Jupiters are gas planets that are extremely close to their parent star, making them the hottest and most extreme exoplanets. The actual appearance of HD 18973b can be misleading, as it has a blue hue caused by light scattering in its atmosphere, similar to the mechanism that makes the sky appear blue on our Earth. Initial measurements showed that this planet also has water, or at least humidity in its atmosphere. But the similarities with beautiful water worlds or our Earth end here. HD 18973b is an extreme example of an uninhabitable world. Proximity to its star leads to temperatures exceeding 1000 degrees C on the planet's day side, making it certainly unsuitable for any form of life as we know it. Webb's analyses clearly showed the presence of water in the form of water vapor. While the discovery of water in an exoplanet's atmosphere would normally cause excitement for the possibility of life, HD 18973b's conditions are so extreme that it can be ruled out. The weather conditions on HD 18973 must be extraordinarily violent. It is believed that there are extreme winds on this planet that can reach speeds of 7,000 km/h. These winds are strong enough to hurl particles and molecules around the planet. The planet is likely raining what we can best describe as molten glass. The high temperature and fierce winds whip the planet horizontally, and on the night side, the heated particles cool down and rain down as molten glass. HD 18973b is certainly not a candidate for the discovery of life, yet it is an extraordinary exoplanet and just one of a series of extreme worlds. Another bizarre world is Kepler-70b. So far, we have found almost more extreme planets in space than Earth-like or potentially habitable ones. If we look at our solar system, we must also admit that inhospitable planets predominate. Venus, with its toxic atmosphere, Mercury, Jupiter, and Saturn, whose gravity would immediately crush a human, or the extremely cold planets in the extreme regions of the solar system. Kepler-70b is another extreme world, far from our Earth. This planet, also known as KY-55b, is about 4,000 light-years away from Earth in the constellation Cygnus. Kepler-70b is also remarkable because it orbits extremely close to its parent star. This exoplanet has an orbital period of only 5.76 hours, which means it is incredibly close to its star, practically moving on its surface. Naturally, this proximity does not come without consequences. Kepler-70b is literally burning near its star. Extremely high temperatures on the planet's surface are estimated at over 600 degrees C, making it hotter than many stars and completely unsuitable for any form of life as we know it. Kepler-70b is a so-called burnt planet. It is believed that this planet was originally a gas giant that is now being consumed by its expanding parent star. Kepler-70b is in the process of transforming into a red giant star and exploding as a supernova. What we recognize today as a planet is actually just the molten core of a former gas giant. This excitingly demonstrates that gas planets could have solid cores and thus surfaces. However, it is also conceivable that solid material formed only through the extreme heat transformation processes. Although this world actually represents a terrifying scenario, K2-18b is a real treat for scientists. Never before have researchers been able to study so well what happens to planets whose parent star transforms into a supernova. It is a bit scary to think that the same scenario will eventually happen in our solar system. However, our sun has only 4.5 billion years before it starts to slowly expand and engulf its planets. K2-18b also has a nearby planet, K2-70c, which is very close to the star and has an orbital period of about 823 hours. Presumably, the growing star literally attracts its planets and then slowly burns them. Thanks for watching. Subscribe to the channel and leave a like to support us.